Before we look at factoring by grouping, let's remember what happens when we factor a trinomial into a product of two binomials. We can represent what's going on with an area model, and we can also remember that when we multiply the two binomials together, we use the distributive property. If we multiply the first terms of the binomials together, we'll get the x squared. So x times x is really our only possible way to do that. If we multiply the last terms of the binomials together, we get -5. Now there's more than one way to do that. It could be +5 times -1 or -5 times +1, but the correct combination is -5 times +1, and that's because the product of the outer terms and the inner terms in our binomials have to combine to give us the middle term in our trinomial, the -4x. And the -5 and the +1 are the right combination to do that. So that leaves us with the factored form of our trinomial, x minus 5 times x plus 1. So let's get to factoring by grouping. We're going to use that to factor this polynomial, and what you probably notice is that it has 4 terms instead of 3. That's a pretty good hint that you're going to be able to use factoring by grouping if it will factor. And in this case it will. This will factor into a product of two binomials. Since it's the product of two binomials, we can represent it with an area model. And what we'll be able to do is say that each term of our polynomial represents an area of one of the 4 smaller rectangles within our area model. So now what we'll do is look at the first row of our area model, the x squared and the 3x, and we'll notice that there's a common factor of x between those two terms. The second row, the xy and the 3y, have a common factor of y. Now look at the first column. The x squared and the xy have a common factor of x. And the second column, the 3x and the 3y, have a common factor of 3. So we've got it. We've got the two factors that we're looking for, x plus 3 and x plus y. Those two factors, when multiplied together, will give us the polynomial we started with. So here's the question. Can we do this same factoring process without drawing an area model? Yeah, the area model actually makes it really easy because we can see what's going on. But the things that were happening when we were looking for common factors, we can still do without an area model if we remember to look for greatest common factors. Okay, here we go. Let's see how this works. What we're going to do is take our original polynomial and see what happens if we think of it as two groups of terms. The first group has the x squared plus 3x in it. The second group has the xy plus 3y in it. In the first group, we can see a common factor of x. And if we factor the x out of the two terms, that will leave us with a factor of x plus 3. Same thing for the last two terms. They have a common factor as well, but in this case it's y. And if we factor the y out of those two terms, that will leave us with an x plus 3. Okay, we've got the think work done. Now let's go back to our original polynomial and see what's really going on. The x squared plus 3x, we said, have a common factor of x, so we can rewrite those first two terms as x times x plus 3. And the last two terms had a common factor of y, so we could write them as y times x plus 3. So now we've really created two big terms that each have a factor of x plus 3. So we'll factor that common factor out, and then multiply it times the leftover factors in the terms, which are the x plus y. So there we go. We've got our polynomial factored. Now let's see if we can tie this back into the model, because we got the same answer with the model, but how does this all fit together? Well, the first group, the x squared plus 3x, that was our first row. And our first row had a common factor of x. And if we multiply x times x plus 3, we have the area of the first row. Our second group, xy plus 3y, that's just our second row. And the common factor in that row is a y. And if we multiply y times x plus 3, we have the area of the second row. So you can see the area model is helpful in factoring by grouping, but it's not necessarily something you have to draw. You can if it helps you to see what's going on. You want to try one more? Okay, let's do it. Okay, here's our next problem. We're going to factor 2x squared plus 3x minus 6xy minus 9y. Now, if we're factoring using an area model, we would put each of those terms into one of the four rectangles. But let's kind of go back and forth between the two representations, the polynomial and the area model, to see what's happening. The first two terms in our polynomial are 2x squared and 3x. That's the two terms in the first column. The common factor is x, and then the leftover factors are 2x and 3. X times 2x is 2x squared, x times 3 is 3x. Now we have to be a little careful with the second group, the negative 6xy minus 9y, because the common factor here is negative. It's negative 3y. And then the leftover factors from each term are 2x and plus 3. That's because negative 3y times 2x is negative 6xy, and negative 3y times 3 is negative 9y. So now, in these two large groups, we have a common factor of 2x plus 3, and the leftover factors are the x and the minus 3y. So there we go. We've got it factored. Make sense? Okay, fantastic. Remember, you're just looking for common factors, and you're doing that by making groups, which in the area model just means you're looking at rows or you're looking at columns.